Hi, my name is Fadi Mohsen, and today I'm going to present our paper, our work, KotlinDetector, towards understanding the implications of using Kotlin in Android applications. The outline of my talk consists of these points. First, I'll talk about the history, our motivation, our contributions, some of the background information essentials, our methodology, the implementation, the evaluation that we conducted, and finally, I will end up with the conclusion. A bit of history about Kotlin. Kotlin was first introduced or developed and introduced by JetBrains in 2011. And after in 2017, Google officially started supporting Kotlin in Android Studio IDE. In 2019, Google announced that Kotlin is the preferred programming language for Android applications. The reasons why the Google maybe they have chosen this programming language in particular to be a successor for Java is for many reasons, and one of the announced reasons were that it's more expressive and it's more modern and also write safe code. However, our motivation was stemmed from the fact that there has been no large-scale studies to study these claims or to study these reasons or to study the implications of introducing Kotlin into the mobile applications or Android mobile applications development. And the reason when we digged into why, the reason was because there was no tool to begin with that would give you the maybe the usage of Kotlin or the features of Kotlin that are implemented in these applications or Kotlin-based applications. There was no tag datasets that the researchers could rely on. Thus, in the contribution of our work here is a threefold. First, we build this tool, which is the Kotlin detector that would detect the presence and the features of Kotlin in Android applications packages, APKs. And second, we provide a usage or use case scenario on how this tool could be combined with another tool to study the implications, the privacy and security implications of using Kotlin in mobile applications. And third, we collected, implemented, and analyzed and validated, tagged a number of tagged Kotlin-related datasets that could be that you can find by following the link that are provided in the paper. So some of the essentials or background information that is needed to understand Kotlin detector is first, we said that Kotlin detector works only on an APK or does not presume access to the actual source code of an application. Thus, it only works or it works on the APK format, which is the format that is used or adopted or the standard for disseminating Android mobile applications in markets and different stores. So the APK format actually is like a zipped file that contains multiple elements about an application, such as the Android manifest file .xml and the classes.dex, the resources, the assets, etc. And our focus would be on the Android manifest.xml and also the classes.dex. Another point or interesting point that actually contributed to the challenges that we faced in implementing this tool is the fact that some applications actually contains multiple DEX files instead of just one DEX file. Another thing is the obfuscation. The obfuscation has been used or to transfer the source code into a form that is hard for humans to interpret and understand and comprehend. And it has been used by multiple purposes by benign developers and also malicious developers. There are multiple types of obfuscation. To name some of those would be identifier renaming, string encryption, Java reflection, and packing. And the focus of this tool is on identifier renaming because according to a recent or to one of the studies that we found in the literature, there are more than 57% of the applications uses this particular type of obfuscation. And one of the tools also that are used by developers who choose to obfuscate their Android applications is called the Pro Guard. Another also interesting facts or things that to be said here is that the Kotlin actually is not compiled into a native machine code, just like Java. Instead, it is compiled into a Dalvik bytecode, and that runs on the top of the Android runtime or virtual machines. And also, some of the things that also we found through manual inspection of some of the Kotlin-based applications was that the majority of these applications that are using Kotlin are using the Kotlin standard library. And this is actually provide us a key into determining the usage of Kotlin or the presence of the Kotlin based on maybe tracing or in searching for particular feature of this standard library inside the code. So the our tool Kotlin Detector actually provides us or provide researchers, whoever wants to use this tool, with answers to the following questions. First, determines whether an application uses a Kotlin or not. Does the application use Kotlin or not at all, even if it's 1% or one line of code? Second, does the application employs obfuscation? And third, how much of the Kotlin, if this application actually uses Kotlin, how much of the Kotlin standard library is present? Because there is the Kotlin standard library, and also there is the developer own code. And fourth, how much of the application consists of Kotlin code? So we want to see, look into the percentages in comparison to the all lines of code the developer has written, how much of those are actually are Kotlin code. And another question determines what language features are used. We identified a number of features, key features in Kotlin. We want to see if the developer using or make use of these features, because some of these features actually are meant to provide or added value to the applications, such as safety and privacy. And the last one is, even for these features that we identified, we want to see how frequent the developer has used these applications. In answering these questions, we employ different strategies or methods, such as invocation tracing, pattern scanning, and also parsing the manifest file. So this diagram shows an overall view of the steps and methods that we applied in order to answer all of these questions. So to the left, we start with the list of data sets of applications, APKs. We feed these applications to the detector. The detector would decompress each one of these applications and extract both the XML file and also the classes of text, which contains the source code, and then save those each one of them into a byte array, as a byte searchable array. And now, when we search the Android manifest, we try to allocate or to identify the package or the path to the package files, because the app actually contains codes that are written by the developer, and also there are some other libraries and packages that are imported into the code. So we wanted to see where does the developer storing the source code, the actual source code. So we want to find the path to this source code from the manifest file. And from to the bottom here, we look at the pattern scanning. We search for the byte array that contains the classes, the DEX, and we look for a particular actually signatures that belong to a component of the Kotlin standard library, because we want to determine the presence, whether there is any hint of Kotlin inside this application or not. Also, we use this to search for a byte that belong to a method or a feature of Kotlin language inside this byte array. And finally, we once we identify these particular methods of different methods that are belong to the library or the Kotlin standard library, we do something called the invocation tracing, because we want to see where in the source code this particular method has been invoked, so that we can mark these particular methods as Kotlin, and also the classes that contains these methods as Kotlin. And this would help us in determining the usage of Kotlin and producing the different percentages. So the implementation, we implemented this using a C++. We chose C++ because it's fast and also flexible and enables us to do all the things that we just discussed. In addition, also we took advantage of other libraries such as the libzip library and also the Android binary XML decoder library. In evaluating our work, we have to collect some data sets, and also we have to implement some. These data sets that we collected were just some of which actually were hand picked manually, so that we want to make sure that these applications contains Kotlin based on the provider announcement or websites. And then also we collected data sets from the F-Droid. The F-Droid contains open source applications. These the source code are actually hosted on the GitHub, and the GitHub as using actually they have a tool, the linguist tool that provides you with percentages of different languages, including the Kotlin. So we did a comparison between our output and also the GitHub linguist tool. And as you can see in this diagram, there are a lot of similarities between the two tools, even though some of these tools actually has a complete access to the source code, whereas our tool only has access to the APK file. Also, we applied our tool into different data sets over years in 2013 that were collected in 2013, 18, 19, and 20. And we saw the progress. And like in 2013, there was no Kotlin. In 18, there we start seeing some Kotlin-based applications. And then we reached at 2020, and now we're seeing more and more applications are using Kotlin. Additionally, also we looked at this fact or the size of the application on the performance of our tool actually, and there is some correlation between the size and also the time it takes to do so. Also in looking at evaluating the accuracy of our tool in identifying the different features of the Kotlin, we implemented 5 applications with different features, and we obfuscated these applications, and then we ran our tool on these applications. And as you can see in the top right, we see that all of these features were identified in the 5 different unobfuscated applications, whereas in the obfuscated there are only just one feature, which is the reflection that was not detected by our tool. Also, lastly, we present here a use case scenario of our tool, where we combine the output of our tool with which is in particular one feature, which is whether the application has a Kotlin or not, and the output of another tool, AndroBugs, that produces our output, the set of vulnerabilities that are existing in these APK files, and we try to find some correlation between whether an application has Kotlin or not, with the number of vulnerabilities in each one of these 4 categories that the AndroBugs produces. And actually, we found some a little bit not strong, but some applications or some leads that could lead us into more concrete results. And finally, we conclude this paper by reminding the audience that this paper is meant to or has implemented or introduced KotlinDetector tool that is meant to detect the presence and the features of Kotlin APK files. We presented a scenario on to how we can use this into studying the implications of Kotlin, and also we hope that our tool and the labeled datasets that we implement actually disseminated is going to be used or serve as a benchmark for further investigations in this field. Thank you.